Hi, so let's look at the introduction to matrices, and we'll just be looking at the forms of matrices and what do we mean by matrices and all that. So we have when we're talking about matrices, we can first look at their forms. Okay, we can have this is a matrix, and automatically this is just a 2 by 2 matrix because we have this is a row by column, and these are rows and these are columns, and our rows are just 1 2 and our columns are 1 and 2 here. So we've known our rows and we've known our columns. Okay, so these are rows and these sides we can call them columns. And now apart from that we can have these since okay, so we are saying these are rows, so we have 1 2 and 3, so we can have 3 by how many columns? We have 1 and 2, so we have 3 by 2. Let me just write that nicely. Okay, 3 by 2 matrix. So this is what they mean when they talk about a 2 by 2, a 3 by 2, and sometimes they'll give us most of the times in 140 they'll give us a 3 by 3. So this is a 3 by 3 according to what we have explained. So let's quickly look at special functions. So special functions, you discover that special functions, special matrices have all their values in a matrix as 0. This is one of the examples of a special. These are special matrices. All the elements in that matrix is 0. So those are what we call special matrices. Okay, so we also have identity matrices. An identity matrix looks like this. So for a 3 by 3, an identity matrix is like this. So this is a 3 by 3 identity matrix, and this is a 2 by 2 identity matrix. So if they talk about any identity matrix, just know that they want your matrix to look like that. So remember this, we'll be using this mostly in our when we start talking deep about identity matrices. So we also have a transpose matrix. So this is our matrix A, and this is a transpose matrix A. If you look at what we've done here, this column has become a row, and same applies to that. So this is what it means when they say transpose A. When they tell you to transpose A, they just mean that make a column become a row on both sides, and these are the sides that we've looked at, and this is how it becomes when you transpose a matrix. So also know how to transpose a matrix. So just a quick introduction on addition and subtraction of matrices. Subtraction. So let's start with the additional part. Okay, addition. If we have our matrix as 5 3 and 2 1 plus 6 1 0 1, what is our final matrix? So what we're going to do is just we're going to add this one here to that one to have 11, and add this to that one, we're going to have 4, add this one there to 0, we have 2. We have 1, and add it to another 1 which is there, and we have our 2. So this is our final answer when we are looking at the addition of matrices. And if we are looking at the subtraction of matrices, then we have matrices as 3, 5, 7, 1, 0, 1, minus 5, 6, 3, 1, 1, 1. Then we are saying this subtract that, we have a negative 2. This subtract that, we have a negative 1. This subtract that, we have a 5 there. Then this subtract that, we have 0. This subtract that, we have negative 1. This subtract that, we have 0. And this is our subtraction rule. Now, if you have observed under this subtraction and addition, you find out that we can only, so the rules are that rules of subtraction and addition, you find out that one rule is that we must have the same column, okay, of two matrices that we are subtracting, or several matrices that we are subtracting or adding must have the same column, and we must have the same rows. So if, for example, so this means that if we have 5 1 and 6 1, 6 1, and they tell you to subtract, how are you going to subtract this and that and this and that? What are you going to subtract with the last column? What are you going to subtract the last column with? Meaning that you cannot subtract the last column because here we have we don't have anything. So we can say these rules are going to stand. So for addition and subtraction, we have those rules. Okay, so this is just an introduction video on matrices and addition and subtraction of matrices, to which we have looked at. And just for practice, look at Tyloka's book. And just look at the exercise that is there. Okay, and just practice on addition and subtraction of matrices. The next video I shall look at scalar matrices and also matrix multiplication. And it's going to become interesting when we start looking at the other part, which is the application of matrices. So firstly, I'll look at scalar and multiplication of matrices. Then later, I shall spend much time on application.